Once again, welcome back with another interesting questions of your class 9 math. Here I am going to discuss a problem based on quadrilateral of your chapter quadrilateral. Okay, understand? So it is one of the interesting questions, and using the concept of midpoint theorem and converse midpoint theorem I am going to discuss. Okay, a problem based on quadrilateral. Shall we see? Yes, let's see the problem. What is the question? Let's see. Okay, here is the problem in front of you, and it is geometrical statements in front of you we are going to prove. Here the problem is that P is the midpoint of the side CD of a parallelogram ABCD. Okay, a line through C, a line is drawn through the point C parallel to PA, intersect AB at the point Q, and DA produced at the point R. Prove that DA is equal to AR and CQ is equal to QR. Understand the questions? Okay. Let's see the diagram. You see in front of you here ABCD is a figure in front of you. ABCD is a parallelogram. Okay. And P is the midpoint of the side CD of the parallelogram ABCD. And again CR is drawn which intersect through the point C. CR is drawn through the point C. Okay, which intersect the side AB of the parallelogram ABCD at the point Q. Okay, and DA produced at the point R. Understand? And we have to prove that DA is equal to AR. We have to prove that DA is equal to AR. Yes, we have to prove that what? DA is equal to AR. We have to prove DA is equal to AR. DA is equal to AR. Yes. Understand? Okay, we have to prove that DA is equal to AR. Understand? It means A is the midpoint of DR we have to prove. Again, second point we have to prove CQ is equal to what? QR. It means Q is the midpoint of CR. Understand others? Is it clear? Understand what is given, what to prove? Okay. Okay, let's see. Okay, dear students, you see here ABCD is a parallelogram. Is given that. And according to, let's see how to prove here. You see here, you see in the parallelogram ABCD, okay, and you see P is the midpoint of what? P is the midpoint. P is the midpoint of CD. Okay, P is the midpoint of CD. Even yes, P is the midpoint of the side CD. Understand? Yes, P is the midpoint of the side CD, right? And it is given CR parallel to PA. Okay. Okay, student, can you see here one thing? Look at here. You see DR. Yes. You see now. DR. Look at here. And here. You see now in the triangle CDR. CDR is a triangle. Yes. CDR is a triangle. So in the triangle CDR, are you seeing? Are you able to see? P is the midpoint of what? CD. And P is the midpoint of CD is given. Yes. P is the midpoint of CD given in triangle CDR. Yes. In triangle CDR. Look at here. Right, in triangle CDR. Yes, P is the midpoint. P is the midpoint of the side CD of the parallelogram ABCD. Yes. Again you see the CR parallel to AP. It is given. CR parallel to AB, it is also given. CR parallel to AP. Understand? And dear students, all of you know, okay, in the triangle CDR, P is the midpoint of the side CD and PA parallel to CR. So according to the converse midpoint theorem. So what is converse midpoint theorem? What is converse midpoint theorem? All of you know. And according to the converse midpoint theorem, okay, and we know that a line drawn through the midpoint of one side parallel to other side bisect the third side. Okay, here the line segment PA is drawn parallel to CR of one of the side of the triangle CDR through the midpoint P, okay, of the side CD. So naturally, according to converse midpoint theorem, A will be the midpoint of ADR. Very simple question. Yes, CR parallel to AP and P is the midpoint of CD. That implies A is the midpoint of what? Midpoint of DR. Yes or no? Midpoint of DR. That implies dA is equal to AR. That implies dA is equal to AR. That implies dA is equal to AR. So this is according to converse midpoint theorem. Yes, according to converse midpoint theorem. Converse midpoint theorem. Is it clear? Understand? So first point is proved. Okay. Understand? So similar process, and you can see here. You can see here. Look at here. And here D, look at here again. Once again, I'm looking this triangle, same cases. Okay, in yellow color lining in the triangle CDR are you looking, and we already proved. Yes, what do you prove here? You prove here what? Yes, A is the midpoint of the side DR, because DA is equal to AR we already proved. Yes, this part already proved. DA is equal to AR, it means A is the midpoint of DR. And again you clearly see here. Again you see clearly, what are you seeing here? The AQ. Yes, AQ parallel to DC. AQ parallel to DC. Yes, AQ line parallel to DC line. AQ parallel to DC. Why? Because AB parallel to CD. Because ABCD is a parallelogram. So similar process according to converse midpoint theorem. Hence A is the midpoint of the side AD. Yes or no? A is the midpoint of the side AD and AQ parallel to CD. So according to converse midpoint theorem, the Q will be the midpoint of Q will be the midpoint. Q is the midpoint. Q will be the midpoint. Yes, of the side CR. It means CR. It means CQ is equal to RQ. Yes. So write down the same thing here. Yes. Let us see here. So here using converse midpoint theorem we are proving the statement. First part is already proved. First point is already proved. Yes. Again you see in the triangle. Which triangle? In the triangle. In triangle CRD. In triangle CRD. In triangle CRD. Okay, and A is the midpoint of the side AD, of the side DR. Yes or no? Why? Already proved, because we have proved DA is equal to AR. Already we have proved it. This is already proved. Yes, this is already proved. This is already proved. Since proved. Understand or not? And AQ parallel to CD. Why? Since AB parallel to CD, opposite sides are parallel. Yes or no? So according to converse midpoint theorem, we can also prove Q is the, so that implies we can write Q is the midpoint. Okay, very simple question says that we are using prove it, and Q is the midpoint of the sides here, right? Understand? By converse midpoint theorem. By converse, yes, by converse midpoint theorem. By converse midpoint theorem. It means we can prove CQ is equal to RQ. Understand? Yes. So the second point, what we are going to prove, okay? Thus we got CQ is equal to RQ, and the first point we already proved, dA is equal to AR. So is it clear? Understand? Okay. So I hope you'll understand it. Okay. Let's follow and practice. Thank you.